Hello everyone and welcome to another scientific video with Temperature reactions, and today in this video we are going to discuss how to calculate the temperature of the sun in a very easy method. First of all, I am going to make the same request from all of you. If you have not subscribed my channel so far, please do it, because this particular channel is little by little providing you the knowledge that you have been waiting for, and little by little this particular channel is going to be one of the largest scientific vlogging channels in the world. And let's move on to today's video. Today our focus is to discuss how to calculate the temperature of the sun. The temperature of the sun, how to calculate. First of all, I'm asking one question. Can we put a thermoprobe or thermometer like this or like this to the sun to calculate the temperature? This is to the outside temperature and this for the inside temperature. Can we do like that? No, because first of all, the thermometer will be melted. That much sun is hot. So we must have, but still we know that surface temperature of the sun is 5772 Celsius and the inside temperature is 15 million Celsius. We know that, very well we know that. But how can we calculate this? Actually, the way is very simple. What we are using here is called the Wien's distribution law. Wien's distribution law. In the Wien's distribution law, what it says is any hot object emits radiation, a spectrum of radiation, not just single radiation, spectrum of radiation. That spectrum consists of electromagnetic rays like light, infrared, or UV, or gamma, or whatever. Anyway, the spectrum will consist of EM waves, electromagnetic waves. And one more thing, Wien's distribution law says that the highest intensity in the spectrum, the highest intensity is wavelength. The wavelength of the radiation which shows the highest intensity in the spectrum is significant for that particular temperature. Means any hot object emits a spectrum, electromagnetic spectrum. In the spectrum, there's one wavelength which shows the highest intensity. That particular wavelength is significant to that particular temperature. So now the point is very clear how to calculate the temperature of the sun. What we have to do is we have to take the solar light, the radiation emitted by the sun. We have to split that radiation using a prism or any method. Using a prism or any other method. We can split the radiation and we can check the intensity ray by ray, radiation by radiation, one by one, light by light. We can calculate, we can measure the intensity. And we can find out which particular radiation has the highest intensity, which particular wavelength has the highest intensity. That particular wavelength tells us how hot the sun is, or the temperature of the sun. Okay, that is the clear point here. You can see here the hot object. There's a hot object. It emits radiation, and this is the intensity. Y-axis is the intensity. Wavelength goes to the x-axis. Now here you can see two spectrums are there. This one for the T1 temperature, one temperature. That temperature, the significant wavelength is λ1, let's say. If the temperature goes up, if the temperature goes down, wavelength gets longer than that. So the spectrum goes to this way. Now here, at another temperature, there will be another spectrum emitted by the hot object. And in that particular spectrum, the highest wavelength will be this one. And this wavelength shows this temperature, and this wavelength shows this temperature. This is the point that we are going to use. So we are taking the solar energy, solar radiation, we are splitting it, and we are checking radiation by radiation which shows the highest intensity. And using the highest intensity, we can calculate the temperature of the sun. Okay, now let's go to the Wien's distribution law. Wien's distribution law says like this. The wavelength of the radiation which shows the highest intensity is indirectly proportional with the absolute temperature of the hot object. Absolute temperature means not the Celsius temperature but the Kelvin temperature. Any Celsius temperature plus 273 will get the absolute temperature. Absolute temperature is the temperature which shows directly how much of thermal energy is consisting inside the hot object. Means how much of thermal energy is there inside the hot object is displayed by the absolute temperature. How to take it? take the Celsius temperature at 273. You'll get the absolute temperature. Okay. Now, the Wien's definition also says lambda max, or the wavelength which shows the highest intensity, is indirectly proportional with the absolute temperature. So we can make an equation: lambda max times absolute temperature is equal to a constant. This constant is called the Wien's constant, 2.898 times 10 to the power minus 3 meters Kelvin. Now we can go to the spectrum of sun. When you split the radiation of the spectrum of sun, you can see few bumps, few radiations, few spectrums are there. But two spectrums are very significant. First spectrum, which shows the highest intensities, that is the spectrum emitted by the surface of the sun. There's another tiny bump at the end. There's another spectrum, tiny spectrum. We can see that spectrum is the spectrum emitted by the inside temperature of the sun. Now, first of all, we are going to calculate the outside temperature of the sun. Okay. Now, this particular most significant spectrum, the highest intensity of that particular spectrum is given by the wavelength 479.4 nanometers. 479.4 nanometers. That is the wavelength which shows the highest intensity. Now we are going to apply this particular wavelength in the equation. Lambda max times T is equal to 2.898. Now lambda max is this one, nanometers. So 479.4 times 10 to the power minus 9 nanometers means 10 to the power minus 9 meters. 10 to the power minus 9 times T is equal to 2.898 times 10 to the power minus 3. Now T is equal to 2.898 times 10 to the power minus 3 divided by 4.794 times 10 to the power minus 6. Finally, this goes down. Finally, from this calculation, we will get a Kelvin temperature. So, final calculation will give us the value 6045 Kelvin. 6045 Kelvin temperature is coming as the surface temperature. But by deducting 273 from this particular value, we can take the Celsius temperature of the surface of the sun. So finally, you will get the Celsius temperature 5772 Celsius. That is the surface temperature of the sun. Now next, we are going to use this particular tiny spectrum to calculate the inside temperature. And let's go to that part. Okay, now we are going to calculate the inside temperature of the sun. For that, we are using this tiny bump. Tiny bump means the spectrum produced by the center of the sun. Why is it like a tiny bump? Because a huge amount of radiation is produced by the center of the sun. But the problem is, as those radiation are coming through the sun's body, the materials of the sun's body is absorbing most of those radiation. So the amount of radiation coming from the center to the outside is very little. That's why it looks like a tiny bump. Anyway, this particular wavelength can be used to calculate the temperature of the sun. So we are using the highest intensity wavelength of that tiny bump to calculate the inside temperature of the sun. Now we are using the same equation, lambda max times T, the times temperature is equal to 2.898 times 10 to the power minus 3 meters Kelvin. Now lambda max is 0.193 nanometers, or 1.93 times 10 to the power minus 2 meters, times temperature is equal to 2.898 times 10 to the power minus 3 meters Kelvin. And now the temperature is equal to 2.898 times 10 to the power minus 10 divided by 1.93 10 to the power minus 10. Finally, once you calculate this final value, you will get 1.5 times 10 to the power 7 Kelvin. 1.5 times 10 to the power 7 Kelvin means 15 million Kelvin. Now, when the value is very huge, whether it's Kelvin or Celsius doesn't matter, because the difference is only 273. So we can take the same value as the Celsius temperature. So inside temperature of the sun can be set as 15 million Kelvin or 15 million Celsius. So this is the way to calculate the surface temperature and the inside temperature of the sun. It's very easy, very simple using Wien's distribution law. So thank you for watching the end of another scientific video. If you like the video, you can like it. If you like the channel, you can subscribe it and you can share in your social media as a help for us. Okay. Thank you very much again for watching this particular scientific video, and let's meet again with a very valuable scientific video same like this, and till then have a good time. Thank you very much.